from chapter Introduction to Trigonometry. So in the first question, they've given that in triangle ABC, right angled at B, the length of AB is 24 centimeters and length of BC is 7 centimeters. We need to determine sine A, cos A, and secondly, we need to find out sine C and cos C. So first, before we move on to finding sine A, cos A, sine C, and cos C, we need to first figure out the unknown value AC. And we can find out the unknown value using the Pythagoras theorem. The Pythagoras theorem states that the hypotenuse squared, which in this case is AC squared, is equal to the sum of the squares of both sides, which is AB squared plus BC squared. So AC squared is equal to AB squared, 24 squared, which is 576, plus 7 squared, which is 49. So when we add 576 and 49, we will get 625. And AC is the root of 625, which is equal to 25 centimeters. So the value of AC is 25 centimeters. So first, we need to find the value of sine A. So we know that sine A is opposite by hypotenuse. So here, they're asking us to find sine A. So the opposite side to angle A is BC, which is 7. And the hypotenuse in this triangle is 25. So sine A is 7 over 25. Secondly, cos A. So cos A, we know, is adjacent by hypotenuse. And the adjacent side to angle A is 24. And the hypotenuse is 25. So this is the value of sine A, and this is the value of cos A. So here, they're asking us to find, in the second question, they're asking us to find sine C and cos C. So for sine C, we know that sine C is equal to opposite by hypotenuse. And in this case, the opposite side to angle C is 24, and the hypotenuse is 25. Similarly, we need to find cos C. So we know that cos C is adjacent over hypotenuse, and the adjacent side to angle C is 7, and the hypotenuse is 25. In the second question, in figure 8.13, which is this figure, we need to calculate tan P minus cot R. So in order to calculate tan P minus cot R, we first need to find the unknown side, which is QR, and then we need to find tan P and cot R separately, and then we're going to substitute the values of tan P and cot R to find tan P minus cot R. So in order to find QR, we know that using the Pythagoras theorem, we know that hypotenuse squared, which is 13 squared, is equal to the sum of the squares of both sides, which is 12 squared plus QR squared. 13 squared is 169, and 12 squared is 144 plus QR squared. So 169 minus 144 will give us 25, which is equal to QR squared. And the value of QR is equal to 5. So now we need to find the value of tan P. So we know that tan P is opposite by adjacent. And for angle P, the opposite side to angle P is 5. And the adjacent to angle P is 12. Similarly, we need to find cot R. We know that cot R is the reciprocal of tan, which is adjacent over opposite. And here, for angle R, the adjacent side to angle R is 5. And the opposite side to angle R is 12. So the value of tan P and cot R are the same. And now we need to find the difference of cot R from tan P. So we need to find 5 by 12 minus 5 by 12, which will give us 0. In the third question, they've given, if sine A is 3 over 4, we need to calculate cos A and tan A. So, for better understanding, let's draw a right angle triangle with angles A, B, and C. So you're given that the value of sine A is 3 over 4, and we know that sine is opposite over hypotenuse. And here, the opposite side to angle A is BC. So that means we can take the value of BC as 3. Similarly, the hypotenuse value is 4, since sine A is equal to opposite by hypotenuse, which is equal to 3 over 4. So the value of AC is 4. Now, in order to find cos A and tan A, we need to find the value of the unknown side. So in order to do that, we're going to use the Pythagoras theorem, which states that AC squared is equal to AB squared plus BC squared. And AC squared is 16, and AB squared is 9, plus BC squared. And we need to bring 9 over to the left-hand side. So when we subtract 9 from 16, we'll get 7, which is equal to BC squared. So the value of BC is equal to root 7. So now we need to find the value of cos A and tan A. So we know that cos A is adjacent over hypotenuse. And looking at the angle A, the adjacent side is root 7 and the hypotenuse is 4. And tan A is opposite over adjacent. And the opposite side to angle A is 3, and the adjacent side to angle A is root 7. So these are the values of cos A and tan A. In the fourth question, they've given 15 cot A is equal to 8, and we need to find sine A and secant A. So since 15 cot A is in multiplication, when we need to isolate cot A. So we can say that cot A is equal to 18 over 5, as when 15 is multiplication brought over to the right-hand side, it becomes division. So now that we know the value of cot A, which is also equal to adjacent over opposite, so let us draw a right angle triangle for better understanding. So we'll name this ABC, and they've given that the value of cot A, which is adjacent over opposite. So we'll take this as angle A, so the adjacent side to angle A would be AB, which is 8. And then the value of the opposite side of angle A, which is BC, is 15. Now we need to find the value of AC. And the value of AC can be found out by the Pythagoras theorem, which states that AC squared is equal to AB squared, which is 64, plus BC squared, which is 225. So AC squared is equal to 289, and the value of AC is equal to 17. So now that we know the value of 17, we can find the value of secant A and sine A. So first of all, we know that the value of sine A is opposite over hypotenuse, and the opposite side to angle A is 15, and the hypotenuse is 17. And similarly, secant A. We know that secant A is the reciprocal of cos A, and cos A is adjacent over hypotenuse, so secant A will be hypotenuse over adjacent. And the hypotenuse is 17, and the adjacent side to angle A is 8. So the value of sine A is 15 over 17, and the value of secant A is 17 over 8. In the fifth question, they've given that secant theta is equal to 13 over 12. We need to calculate all the other trigonometric ratios. So let us draw a right angle triangle named A, B, and C. And they've given that secant theta is equal to 13 over 12. So let us assume that angle A is equal to theta. And since they've given that secant theta is equal to 13 over 12, we know that secant theta is a reciprocal of cos theta, which is adjacent over hypotenuse. So secant theta will be hypotenuse over adjacent. So now that we know this, we can say that the hypotenuse value of the triangle ABC will be 13, and the adjacent to angle theta will be 12. So the adjacent side to angle theta would be AB, which is 12. units. So now we need to find the values of sine theta, cos theta, tan theta, cot theta, and cosecant theta. And the value of secant theta is already given. So in order to find the values of all of these, we need to first find the value of the unknown side, which is BC. So we can find out the value of BC by 13 squared is equal to 12 squared plus BC squared. And 169 minus 144 is equal to BC squared. And 169 minus 144 will give us 25, which is equal to BC squared. And the value of BC is equal to 5. So now we need to find the value of sine theta. So sine theta we know is opposite over hypotenuse. So opposite side to angle theta is 5. And the hypotenuse is 13. Next, for cos theta. We know cos theta is adjacent over hypotenuse. And the adjacent side to angle theta is 12 and the hypotenuse is 13. Next, tan theta. Tan theta is opposite over adjacent. And the opposite side to angle theta is 5 and the adjacent to angle theta is 12. Now we need to find cot theta. We know that cot theta is the reciprocal of tan theta, so cot theta is 12 over 5. And we know that cosecant theta is the reciprocal of sine theta, so it'll be 13 over 5. So these are all the trigonometric ratios. In the sixth question, they've said that if angle A and angle B are acute angles such that cos A is equal to cos B, we need to show that angle A is equal to angle B. So they've given that cos A is equal to cos B. So the value of cos A would be adjacent, which is AC. Hold on. Cos A is adjacent AC over hypotenuse AB. And cos B is equal to adjacent, which is CB, over AB, which is the hypotenuse. So they've said that the values of cos A is equal to cos B. So then we can write this as AC over AB is equal to CB over AB. And AB and AB will get cancelled, so we can say that AC is equal to CB. So AC is equal to CB. We know that angles subtended by equal sides are equal. So both angles A and angle B are subtended by equal sides. Since AC is equal to CB, that means both the sides AC and CB are equal. And since angle A and angle B are subtended by equal sides, we can say that angle A is equal to angle B. Since angles opposite, equal sides are equal. In the seventh question, it said that if cot theta is equal to 7 over 8, we need to evaluate 1 plus sine theta times 1 minus sine theta over 1 plus cos theta times 1 minus cos theta. So first, in order to evaluate this, we need to first find the values of sine theta and cos theta. So let us suppose that this is a right angle triangle named ABC, and the value of angle A is theta. And they've said that cot theta, which is adjacent over opposite, so adjacent to angle theta would be AB, which would equal 7, and the opposite side to angle theta is BC, which is equal to 8. And now we need to find the value of AC. So AC squared is equal to 49 plus 64. So AC is equal to root 113. So now we need to find the values of sine theta and cos theta. So we know that sine theta is equal to opposite over hypotenuse. And the opposite side to angle theta is 8 and the hypotenuse is root 113. And cos theta is adjacent over hypotenuse, and the adjacent side to angle theta is 7, so 7 over root 113. So now we need to evaluate 1 plus sine theta times 1 minus sine theta and 1 plus cos theta times 1 minus cos theta. We will notice that this is written in the form a plus b times a minus b, which is equal to a squared minus b squared. And we know that the value of a here is 1 and the value of b is sine theta. So when we write this in this format, we will get 1 minus sine squared theta over 1 minus cos squared theta. And we have found out the value of sine theta and cos theta, which are 8 over root 113 and 7 over root 113. So when we substitute the values of sine theta and cos theta, we will get 1 minus whole root of 8 over 113 squared over 1 minus 7 over root of 113 whole squared. And when we simplify this, we will get 1 minus 64 over 113, as the root and the square will get cancelled, and 1 minus 49 over 113. So we're going to make sure that they have the same denominator, so we're going to cross multiply, and when we do that, we'll get 113 minus 64 over 113 divided by 113 minus 49 over 113. And 113 and 113 will get cancelled, so we will be left with 113 minus 64, which is equal to 49, and 113 minus 49, which is equal to 64. So this is the answer. In the second question, they're asking us to find the value of cot squared theta. And we know that cot theta is equal to 7 over 8, and cot squared theta is equal to 7 by 8 the whole squared. And 7 by 8 the whole squared will give us 49 over 64. So cot squared theta is equal to 49 over 64. In the 8th question, they've given that if 3 cot A is equal to 4, we need to check whether 1 minus tan square A over 1 plus tan square A is equal to cos square A minus sin square A or not. And they've given that 3 cot A is equal to 4. Since this is in multiplication, when we bring it over to this side, isolating the cot A, we will get 4 over 3. And we know that cot A is equal to adjacent over opposite. And we need to find the values of tan and cos and sine separately, and then we'll substitute those values into this equation to see if they're equal or not. And we know, in order to find the remaining values of cos and sine, let us assume that this is a right angle triangle ABC, where the value of angle A is equal to, where this is angle A, and then they've given that the adjacent side to angle A is 4. So the adjacent side to angle A is AB, which is equal to 4, and the opposite side to angle A is 3. And we need to find the value of AC. So we know that AC squared is equal to 16 plus 9, and AC is equal to root of 25, which is equal to 5. And first we need to find the values of tan, sine, and cos separately. So first we know that tan A is the reciprocal of cot A, so tan A is equal to 3 over 4. Cos A is adjacent over hypotenuse. The adjacent side to angle A is 4 over 5, and then sine A is opposite over hypotenuse. Opposite is 3 and hypotenuse is 5. So now we're going to substitute these values in this equation to see if they are equal. So first we need to find 1 minus tan square A. So 3 by 4 the whole squared over 1 plus 3 by 4 the whole squared. We need to check if it's equal to cos square A minus sin square A. So cos square A, which is 4 by 5 the whole squared, minus 3 by 5 the whole squared. So when we simplify this, we will get 1 minus 10 by 16, 1 minus 9 by 16, and 1 plus 9 by 16. And we're going to make sure that they both have the same common denominator. So we can write this as 16 minus 9 by 16 and 16 plus 9 by 16, where 16 and 16 will get cancelled. So you will be left with 7, 16 minus 9, which is equal to 7, and 16 plus 9, which is equal to 25. So now we need to check if 7 over 25 is equal to 4 by 5 whole squared minus 3 by 5 the whole squared. So 7 over 25 is equal to 4 squared, which is equal to 16, by minus 3 squared, which is 9, over 25. And 16 minus 9 is equal to 7 over 25, hence we can say that 1 minus 10 squared a by 1 plus 10 squared a is equal to cos squared a minus sin squared a. In the ninth question, they've given that in a triangle ABC, right angled at B, if tan A is equal to 1 over root 3, we need to find the values of sin A plus sin A times cos C plus cos A times sin C. So they've said that imagine there is a right angle triangle, ABC, right angled at B. So A, B, and C, right angled at B. They've given the value of tan A as 1 over root 3. We know that tan A is opposite over adjacent. So the opposite side to angle A is BC. So the value of BC is 1. And the adjacent side to angle A is AB, which is root 3. So we need to find the value of sin A times cos C plus cos A times sin C. In order to find the value of sin A and cos A, we need to find the value of AC. So we know that AC squared is equal to root 3 squared plus 1 squared. And AC squared is equal to 3 plus 1. So AC is equal to root 4, which is equal to 2. So now we need to find the value of sin A. So sin A is opposite over hypotenuse. The opposite side to angle A is 1 and the hypotenuse is 2. And cos A. So cos A is adjacent over hypotenuse. The adjacent side to angle A is root 3 and the hypotenuse is 2. Now we need to find the value of sin C, and sin C is opposite over hypotenuse. The opposite side to angle C is root 3 and the hypotenuse is 2, and we need to find cos C, and cos C, the adjacent side to cos C is 1 and the hypotenuse is 2. So now we need to find sin A times cos C plus cos A times sin C. So sin A times cos C is 1 over 2 times cos C, which is 1 over 2, plus cos A, which is root 3 by 2, times sin C, which is also root 3 by 2. So 1 by 2 times 1 by 2 is 1 by 4, plus root 3 times root 3 is 3, and 2 times 2 is 4. And when we add 1 by 4 plus 1 by 3, we will get 4 by 4, which is equal to 1. In the second question, they're asking us to evaluate cos A times cos C minus sin A times sin C. We already found out the values of cos A, cos C, and sin A, sin C. So substituting the values of cos A and cos C, we will get root 3 by 2 times 1 by 2, and minus sin A, which is 1 by 2, times root 3 by 2, which is sin C. So when we multiply these values, we will get root 3 by 4 minus root 3 by 4. So root 3 by 4 minus root 3 by 4 will give us 0. In the 10th question, they've given that in triangle PQR, right angled at Q, they've given that PR plus QR is equal to 25 centimeters. And PQ is equal to 5 centimeters. We need to determine the values of sin P, cos P, and tan P. So they've given that the value of PR plus QR is equal to 25 centimeters, and PQ is 5 centimeters. So we need to find the values of either PR or QR in terms of either PR or QR. So we can write in this scenario, let us write PR, so hold on, given PR plus QR is equal to 25 centimeters. So let us write PR in the terms of QR. So we need to find the value of QR, and once we find the value of QR, we're going to substitute it in this equation in order to find the value of PR. And so we can say that PR, the value of PR can be written as 25 minus QR. And we can take QR as QR. So using the Pythagoras theorem, we can say that 25 minus QR, since PR can be written as 25 minus QR, since PR is written in terms of QR, so 25 minus QR, which is the hypotenuse, so hypotenuse squared is equal to the sum of the squares of both sides, so PQ squared, which is 25, plus QR squared. And 25 minus QR, the whole squared, is written in the form a minus b the whole squared. So when we simplify this, we'll get 625 minus 50 QR plus QR squared is equal to 25 plus QR. And QR squared. And QR squared and QR squared will get cancelled. So we will be left with minus 50 QR, which is equal to 25 minus 625. And so we'll get minus 50 QR is equal to 25 minus 625 will give us minus 600. So QR is equal to minus 600 over minus 50. And the value of QR will be equal to positive 12. So since we know the value of QR, now we're going to substitute the value of QR in this equation in order to find the value of PR. So PR is equal to 25 minus 12. And 25 minus 12 will give us 13. Now we need to find the values of sine P, cos P, and tan P. So we know that sine P is equal to opposite over hypotenuse. And the opposite side to angle P is QR, which is 12, and the hypotenuse, which we found, is 13. Next, cos P. We know cos P is adjacent over hypotenuse, and we know that the adjacent side to angle P is 5, and the hypotenuse is 13. Next, tan P. We know that tan P is opposite over adjacent. So the opposite side to angle P is 12, and the adjacent side to angle P is 5. So these are the values of sine P, cos P, and tan P.